All right, continuing in activity 2.33, we're going to look at the steps to request a web page. And there are a lot of things that happen behind the scenes when you access a web page. So, you go to your browser, you type in a URL. Um, all these things happen in the background, which it seems like a lot of work. So the first thing that happens after you request a web page is the user's host broadcasts a message asking for the address of the requested web server, and a router will provide that address. So literally, your computer is like, "Hey, internet, tell me where this destination is." It's a very uh, rough way to describe it, but essentially, when you type in google.com, that needs to be translated into the IP address of a server, and your computer doesn't know what that is. So it says, "Hey, what's the IP address to the internet?" And based on some protocols that are set up, the internet knows how to answer that question usually. So after that happens, step two, the user's host initiates a connection request to the web server. It responds, and they perform a handshake to establish a connection. So in this step, the two machines start talking to each other, and they agree on the way that they're going to communicate with each other, and that's the handshake. They kind of agree on this is the way we're going to talk with each other. Step three, the user's host requests the specific web content. So once there's a connection, then the user can actually say, all right, give me data from the web server. And then in step four, the web server actually responds with the content that the user requested. And then finally, the user gets to see what they've asked for. And it's important to know this is all the different steps that occur because these are all steps in which a hacker could do something to interrupt the sequence of events and maybe inject some code or change the process so it doesn't work the way that you intended it to. So we're going to look at step one first. So how does this broadcasting work? So we talked a little bit before about a MAC address, but not so much about what hexadecimal is. So this was a MAC address of a network card for a computer, probably. And this is in what's called hexadecimal, which you don't need to know too much about it, but the way I describe it is that the way we develop numbers is we use base 10, probably because we have 10 fingers. So we have the digits from 0 to 9. But just imagine if we had 16 fingers instead of 10. Well, then instead of going from 0 to 9 and only having 10 characters, we'd have to have 16 different characters, one for each of the different fingers that we have. So that's why in hexadecimal you don't stop at 9, you actually go A, B, C, D, E, F afterwards. So this is a little bit of a hard way to think about what this actually means, but just know that this is a special way to encode a number if you used 16 fingers instead of 10. It's a system that makes sense because computers work in binary and there's a lot of connections between binary and base 16. So one thing you should know about a MAC address is the first kind of three sections here. Uh, they're going to indicate sort of like who made this network card that we're using. If we have received a packet of information from a computer, these first three sections here will be able to identify the brand of network card that generated that information. So we're going to investigate some of that in the virtual machine. So first thing we're going to do is go into here, and we're going to search for a specific packet. I believe the command I need is Control G, and this little packet option will turn up. If I put in 546 and hit go to packet, it'll show me packet 546. That's the one I wanted, right? Yeah. All right. So first thing we're going to look at is what's the source of packet 546. The source MAC address is 0022FA blah blah blah. Now, one thing we want to investigate a little bit, and it's sort of already telling us here, is who is the manufacturer of the network card that generated this packet of information. All right, so we already answered that question. Yes, we have that there. Question here about why do we think this thing at the bottom is called a hex dump? The answer to that is because this is all the hexadecimal data that's inside of the packet. So it's called a hex dump. This is all information that represents real data, but this is not in a human readable format. This is just in a computer readable format, and it'd be very difficult for a human to understand what any of this means. But whenever you're sending information over the internet, it's not encoded in a way that humans read it, it's encoded in a way that computers read, which is usually binary, which is ones and zeros. Here you can see the data is represented in hexadecimal, which is very similar to binary in terms of how computers read information. Blah, blah, blah. Okay. So there's a link here that I've opened up in this other tab. What this is a list of all the different registered sequences of hexadecimal characters at the beginning of the MAC address. And it'll tell you which company made the network card that you're investigating. So like if it started with 3C D92B, we'd know it's from Hewlett-Packard. So the one that we were just talking about started with 0022FA. So I'm going to look for 00, what was it, 00, forgot, my memory is bad, 22FA, so 22FA. And you can see that this was made by Intel. So that's the company that made the network card that generated that packet of information. That could be useful to know because often when you have hackers that are trying to do something nefarious, they will hide their identity by spoofing their MAC address or faking it. And if the first characters at the beginning of the MAC address that you get is not in a list of valid initial sequences, then you know that probably something is up and that's a dangerous packet. So now let's talk about the way that broadcasting works. So we're going to look at another packet, 484. So in Wireshark, Control G, 484. And I'm going to go to that packet. And you can see up here in the info, it says who has 192.168.1.64, and it says tell 192.168.1.254. So this is the the computer that originated the question. So they're going to hopefully get the answer sent back to them. And this is the question that they want is, who has this IP address? You can see there's a protocol here, something called ARP, and the destination is not a specific IP address, it's a broadcast, so it goes to every computer that's on that network. Alright, so next thing we're going to do is we're going to filter so that we only see the packets that matched the protocol of this broadcast. So that's ARP. That's the protocol that was used. So I'm going to type in ARP and hit enter. And so now these are all the packets that were sent out that were doing this kind of like who has this IP address, and then it gets a response hopefully. So then we're supposed to scroll to the top of the packet list, and then we want to see who responded to our request, which was who has this IP address and tell this IP address. So I'm going to go all the way to the top, and it ends up being packet 46. This is just a coincidence, it's the one at the top. But this is the response packet. So this is the one that answers the question for who has this and tell this IP address. So we found it, you can take a screenshot of it. That's pretty much it for this section. One thing you might be wondering, and it's very true, is that if this kind of a question answer is happening all the time, that could really slow down the network. So what a lot of computers do is after they find an answer, they record it so they don't have to ask again. And once we're done, if we want to clear this out for our next section, we're just going to click the X.